This topic will cover radical expressions with operations such as addition, subtraction, multiplication, and division. It can be found in topics 7 and 8 of our Algebra Nation textbook, and it will cover 2 videos. This one we're going to focus on the rules for addition and subtraction, as they are different than those for multiplication and division. So it's important that we understand some foundational concepts. Also keep in mind, simplifying radicals and rational exponents is going to come back into play in this topic. Before we can begin anything, we need to understand what like radicals are. I'm always going to refer to them as variables. Treat them as variables. They're a little different. I know they're not a letter. We know its value, or we can approximate it. But we're going to use that for combining them. They have to have the same root and the same radicand. So if we come down and look here at these green ones, if you notice, the root here is a square root. Since there's no number written there, we call it a square root. The root here is also a square, so that's good. The roots are the same, the index. But now we have to make sure that the radicand, the number underneath, is the same. So since those are the same, both index and radicand, those are like terms. Yes, you might see a 2 sitting out there, but that doesn't mean anything. That just means it's 2 times the square root of 3. Well, when we look at these white ones, the index is 4 here, and the index is 4 here. So we've got one of our check-offs. So far, we're okay. But we also look at our radicand. Here it's a 5, and here it's a 5. Therefore, those are like terms. They're like radicals, okay? Unlike radicals, well, it's the exact opposite of what a like one is. They do not have the same root and same radicand, okay? So if we take a look, here my radicand is 5, and it's also 5 here. So far we'd be thinking, okay, it's the same. We can combine these. But what you have to also look at again is the index. Here my index is a 2, while here my index is a 3. Therefore, they are not like radicals. Even though the radicands are the same, the roots are not. So let's come over and look at these white ones. On this one, we have a 4th root. And we also have a 4th root here. So again, people start thinking, oh, they're the same, I can combine them. But remember, you got to look at both things. So here, my radicand is 2, but here, my radicand is 5. It doesn't work, okay? So why do we need that? Why do we need to know that? Well, when adding and subtracting radicals, we must have like radicals. Again, this is only for adding and subtracting. So I would write this sentence down. Pause it if you have to. Notice how I underline things. That's because it's gonna emphasize this rule is only for adding and subtracting. Okay? So let's go see how that would look. So basically what you want to do is you want to take a look at the radicand and the root. So if you look, here I have 11 and here I have 11. So far, one of my criteria is met. The root here is a 2 since nothing's written there. I also have a 2 here. Therefore, these are like radicals, okay? So what I like to do, I'm just going to write the radical, okay? Then I have to go combine them. What I'm going to look at is their coefficients. Here, I have a 6. Here, I have a positive 9. When I add those two together, I get 15. I have now simplified this problem. I'm done. So let's go look here. Here, my radicand's 3. My radicand's also 3. My root is a 2. Up, root is a 2. I can combine them. So I have to look. What's in front of this square root of 3? There's nothing there, right? But there's a 1. You have to remember, if something's not written in front, there's a 1. So really, I have 1, and then I have -5. Remember those integer rules. Go back and watch the videos that are posted in the description. 1 minus 5 is -4. Okay? Your turn. Pause the video now and just try these. These are very straightforward. Okay, let's see how you did. On the first one we see it's both square root of 2. So my radicals are the same. So all I'm going to do is focus on my coefficients. I have a +7 and I have a -8. This is going back to combining like terms that we did at the very beginning with expressions. So 7 minus 8 gives me a -1. But again, I'm not going to write the 1. But you do have to write the negative in front of your square root of 2. If you don't have that negative sign, it's a completely different value. And you need to get used to seeing it this way. If you need to write the 1 for your sake, go for it. But if this was a multiple choice or multi-select question, you wouldn't see a 1 there. Okay, let's see how you do on the next one. Well, my radicand and my root are the same. It's both square root of 5. So that leaves me with just a 5 in front here and a +2 here. So very straightforward. 5 plus 2 is 7. So these are pretty straightforward, right? Pretty simple to do. Well, what happens when I'm going through? Okay, my roots, they're the same. Perfect. But now I look, I have a 3, and then I have a 12. So I can't combine like terms because these aren't like. But what you have to start realizing is you can simplify that 12. I can take the 12 and simplify that radical. So I go do a factor tree. Again, many factors of 12, but I'm going to go with 6 and 2. You could have done 3 and 4. We never do 1 and 12. There's no point, okay? Then I break 6 down to 2 and 3. Both of those are prime numbers, so I'm not going to have another branch. The 2 was a prime number, so right there, I'm done with my factor tree. All I have to do is write it under my square root. Now, it's a square root, meaning my index is 2. So I want a pair of 2, a pair of whatever I could find. When that pair comes out, I get 2 square root of 3. So really, my problem now is 5 square root of 3 minus 2 square root of 3. So there's something that I want to emphasize. Before you can combine like terms, every radical needs to be simplified. Meaning what's under that radical, I'm going to say radical, I'm not going to say square root because you could have a cube root, you could have a fourth root. Whatever's under there has to be as low as it can go. Everything's pulled out. So now that I'm at this step, I really only have to look at my coefficients, which I have a 5 and I have a -2. When I combine those, I get 3. So make sure you write square root of 3 also. That right there is my final answer. So yes, do you still have to understand topic 6? So very much so in order to do this. You can't do it and you're not simplified until your radicals are as low as they can go. So you know what time it is. Pause. If you haven't gotten it, go back. Make sure you have this written down. And you're going to try it on your own. Okay, let's see how you did. Obviously, when we look, I have a 7 and I have a 28. Those aren't like. So I don't even need to worry about the root because they're not. The 28's different. I got to simplify it. So if I take 28 and I do a factor tree, I'm going to do 7 and 4. 7's prime. I'm done there. 4 just gives me 2 and 2. I put that underneath my square root. Now hold on. There's a 2 outside there. Why? Well, if you go back to the original problem, it was 2 times the square root of 28. I haven't pulled anything out yet, but I'm bringing down exactly the term that I was working with. It's a square root, so I need a pair. When I bring that out, it's now 2 times 2 because of the 2 that started in the original problem. So I get 4 square root of 7. So I have 4 square root of 7 minus 4 square root of 7. 4 minus 4 is 0. And 0 is your answer. Okay? Sometimes they're going to cancel out. But you can't just leave a problem blank. You haven't answered it. It's like saying, what is 3 minus 3? 0. Okay? So I want you to try this one. It's a little bigger. And if you notice, what's different about it is that they both need to be simplified. Okay, so 32, 18. 32 breaks down. I'm going to use 4 and 8. That's just my choice. So 4 breaks down to 2 and 2. Those are both prime. 8 we know is 2 times 4, and we just broke down 4 to 2 and 2. So what I like to do is finish this one off first. Don't go start the other one. Look again, I have the 5 outside from the original problem. It's a square root, so there needs to be 2. Both of those come out, but they come out as their name. Basically, when you bring it out, you're bringing it out as a single entity. So 5 times 2 times 2, that gives me 20 square root of 2. Okay? Now I'm going to go break down my 18. I'm going to use 2 and 9. You can use whatever you want, but this is why I use this. 2's done. 9 is just 3 and 3. I'm done. Now look, I've got my 4 from the original problem. Then 2 times 3 times 3. It's a square root, so I want a partner pair. And I get 12 square root of 2. So that's going to go back up there. Now they're both the same radicals. Now they're like radicals. So I focus on my coefficients. 20 plus 12 is 32. So this is a lot. This is a lot to take in, but you really still need to understand topic 6. So if you got it, click like. Let me know. I want to see how many of you out there understood this. Am I saying you could go teach it? Am I saying you can go take a test on it right now? No. But summarize. Reflect what we just went over. See if maybe there's something you might need extra help on. Don't forget to subscribe.